ఒక్కసారి మీ రెస్పెక్టెడ్ గ్రూప్స్ లో క్లాస్ స్టార్ట్ అయిపోయిందని ఒక్కసారి ఇన్ఫార్మ్ చేయండి అమ్మా. ఓకే సార్, నేను ఫాలోఅప్ చేస్తూ ఉంటాను సార్ బ్యాక్ ఎండ్.
Okay, sir. Continue, sir.
ఓకే సార్.
Right. Okay. So in previous class, we have discussed about data types and literals. In today's class, we are going to see in detail about variables, lifetime of variables, scope of a variable, and also we are going to see about the concept of arrays in detail. So first, let us discuss about what is meant by a variable and what are the different types of variables we are having in our Java. So mainly if you are going to consider a variable. So generally if you are going to consider any Java program, not only Java program, if you consider anything, any programming language, compulsory two elements has to be present. First one is data and second one is methods. These two are very important for any programming language because if you want to execute anything, we require a group of statements. That group of statements are going to be written inside a method. If you want to execute anything, compulsory some data has to be there. For example, if I want to perform an addition, some instructions has to be written for that, and to execute this instruction I need a data. So here if we consider our variable, okay, if you want to talk about a data, basic data will be stored in our variables. So first we have to see about variables where it can take only individual value, and let us see how many different types of variables are there. So generally your variables are going to be divided mainly into first one is primitive variables. Already in previous class we have discussed about primitive data types. So second type is reference variables. Sir, what are these primitive variables? Primitive variables are nothing but if you are going to create any variable with the help of primitive data types, those are called as primitive primitive variables. If we are going to consider reference variables by using let us consider here byte, short, int, and so on, all primitive data types. Coming to this reference, we can take by using a class, we can create this reference variable by using interfaces, by using arrays, and for example, by using enum, enumerations. Okay. So now currently we are going to see about what are different types. Mainly variables are of two types. Again, if we want to divide these variables, we are going to have three types again. First one is instance variable, second one is static variable, and third one is local variable. So now we are discussing in detail with examples about these three data types, sorry, these three variables. Again, I'm repeating, variables is of two types. One is primitive, another one is reference. Again, we can divide the variables into three types. One is instance, static, and local. Sir, initially you told that there are two types. Again, you are telling there are three types. Means in primitive, I can consider instance primitive type or primitive instance, primitive static, primitive local. Or I can consider what? Reference instance, reference static, reference local. Or instance reference, static reference, or local reference. So mainly here we are going to discuss about these three types. First one is instance, second one is static, and third one is local. So observe carefully here. I will discuss in detail. For every point, I am going to give you an example. That is, I am going to write the code, and you can observe the output clearly. So that you can understand every point here. So first point, just I will explain the point. I will go to the program and I will show the output for that particular point. So first point, instance variable. First point is instance variable. I am discussing about instance variables. So first I will write the point and I'm going to give an example for this. Nearly I will explain 5 to 6 points here. For every 5 points, I will write a program here.
మరి ఎందుకు పనులు ఎందుకు అమ్మా?
Okay. So now see, okay, 1 minute. Please, those who are entering into the room, please be in mute. Okay, right. So now see here, I am discussing about the concept of instance variables. For every point, I am going to show you an example. First one, when we have to go for the concept of instance, or first point I want to tell you is, what is instance variable? The variable, first point, the variable that is created inside a class directly, inside a class directly, those type of variables are called as instance variables. The variable that is written or declared inside a inside a class directly. For example, here you can observe a class here. So this class is going to contain one method, that is public static void main, inside a class directly, that is inside a class directly. Here I am going to create int a equal to 10. So now I can say this a as a instance variable. First point is completed. That is, whenever you want to create instance variable, that variable has to be created inside a class directly. So inside a class, what are there? First one is, there is a variable, as it is directly declared inside a class, I can consider this variable as instance variable. And again, this is also one method I have declared here. That means class contains mainly two members. One is data, second one is method. Mainly we are discussing about this data. So sorry, we are discussing about this variable. So that I will only explain about this variable. First point is completed. Second point, sir, if you are going to write this variable, how it can be accessed? How it can be accessed? If you want to access any instance variable, generally there will be two areas. One is instance area. One is instance area and second one is static area. Sir, what is meant by instance area? For example, in a instance method, the area is called as instance area. Inside a static method, the area is called as what? Static area. And also we can consider inside a constructor also, or inside a instance block also. Here also in static block we can consider it as a static area. So static area is nothing but inside a static method and inside a static block. Instance area is nothing but the area that is present inside a instance method, constructor and block. Now what I am discussing about instance variable. So from where we can access this instance variable and how we can access this instance variable. Second point. So if you want to access instance variable from from instance area, we can access directly. I will show you that we can access directly. First point. Next point. Next, coming to static area, if you want to access instance variable from static area, we have to use reference. Or we can say it as a reference or object. Okay, let us see that reference or object. Right, now I will explain about this point. So now see here in my program, what is there? Only this is one method, and this method is which type? Static method. Already I have mentioned you that to access instance variable from static area, we have to use what? We have to use reference, or we can consider it as an object. So I will differentiate what is meant by reference and what is meant by object later. Now, so I have to create what? Object. Already you know that how to create an object. Class name, reference variable, new keyword or new operator, and finally again I have to write a constructor. I have created an object, and now from this area, because this is which area? This is static area. If you want to access this instance variable inside a static area or static method, we have to use what? Object. So that what I can use here? X.a. If I execute this, I am going to get output as, if I am going to execute this, I am going to get output as what? 10. You can observe that. So as already you know that how to compile the Java program and how to execute the Java program, so that I'm not going to explain anything regarding that. Now, finally, observe the output here. So see, I'm going to get answer as what? 10. That means what? To access the instance variable from a static array, I have to use a variable, sorry, reference variable or object. Now observe here, without having that object reference, let us execute that same program once again. So see, it is clearly saying what? Non-static. Non-static is nothing but what? Instance variable. Or instance variable can also be called as non-static. So non-static variable A cannot be referenced from static context. That means what? Directly we cannot refer that. By using what I have to refer? By using a object reference I have to refer. Okay, I can use that. This is first point. Next one, how to refer from instance area? You can, I have written here one point. Instance variable from instance area we can access directly. So here I will take one more member, that is, for example, I'm going to take void high. Here I'm going to take just, I want to access that element. So same here, I will copy and paste the same print statement here. Okay. Now observe carefully here. If you observe this, how many members are there in my class? This is a variable which is considered as instance variable, and these two are methods. Observe carefully. These two are methods. So here I have given a static for the method here. So that is static method, and this area can be considered as static area. And here directly inside a class, I have written a method. Observe carefully one point here. If you are going to write anything inside a class directly without a static keyword, those are going to be considered as instance members. Here this is written directly inside a class without any static keyword, and this is also written inside a class directly without any static keyword. So this is instance method, or we can consider it as a non-static method. And here it is what? Here it is a non-static variable, or we can consider it as what? Instance variable. Now how I can access here? I can access directly, there is no problem. So now if I execute the same program, I am going to get output as, anyway, here I will get, sorry, I have to access, I have to call this method. So again consider same thing here. How I have to call that one? As it is instance member, if I want to access from a static area, compulsory object has to be referred. So I'm going to comment this one. Again I'm repeating. So as this is instance member of a class, if you want to access that instance member from a static area, that means from this area, I have to use object reference. So that I'm going to call x dot high, the control comes here, and I'm going to print output as A. So let us see. So observe here, I'm going to get answer as what? 10 here. Okay. So these 2 points are covered now. Okay. Right. Next point about instance variable. Sir, when instance variable is created and where it is going to be created. Right. Your instance variables are going to be created. Instance variables will be created inside heap memory. Which memory? Heap memory. As a part of object. As a part of what? Object. That means whenever you are going to create any object, instance variables will be available for that object. So I am going to show you the proof for that. So here in this case, how many objects are there? X is there, and I'm going to take one more object for that. See here, one more object. So I'm going to change the reference name here, that is Y. Now in this case, what I am going to do is, just I will remove this. Now see, what I am going to do is, here I want to print x dot a, and also I want to print y dot a. What I told you, here whenever you are going to create first object, 1 minute. Okay. So now observe, Here, whenever I'm going to execute these two statements, what is going to be happen? So first X object will be created and second Y object will be created. What will be the things that are available here? So inside an object, instance members are available. If you see my program here, this is instance. See, observe, this is instance and this is also instance. So these two members are available inside your object. There is nothing but here a equal to 10, in Y also a equal to 10, and high is available here. And here also high method is going to be available. So if I call x dot a, I'm going to get output as 10. If I call y dot a, I'm going to get output as 10. Okay, let us see the program here. So just I am going to execute x dot a and y dot a. So let us see. So sorry, I have not saved the program. One minute. Right. Now see what I'm going to get. I'm going to get answer as 20 because what I have done here, I'm going to add the value of a and value of x, value of a which is present in x and value of a which is present in y. So that I'm going to get answer as what? 10 here. So now I want to show you that separately. Okay. So what I will do here, just I'm going to write a double quotes so that I'm going to get clearly the value of a and the value of b. Right. Observe this. Right. What I got? 10 and 10. That means inside an x there is a, inside a y there is a, because here x and y are pointing to which objects? Both are going to point to which object? Test object. That means what? For every object, instance variable is going to be available. This is very important point to understand. But one more point I want to tell here. See that what I am going to do here? I am going to change the value of, see, I am going to change the value of a which is present in x. That means what? Already I'm having here a in x. Just I'm going to change this value into what? 20. If I change a value in x, will the a value in y is going to be changed? No, it is not going to be changed. So as a proof, I will execute the program once again so that you are going to get answer as what? Here 20 is going to be printed and here you are going to get answer as 10. Okay, let us see that. So see now. So sorry, let us save this. Then I'm going to change x dot a as 20. Okay, right. So see now, I'm going to get answer as what? 20. This is nothing but what? I have changed the a value in x, but y value is not going to be changed. That is, here what I want to give, when we have to go for this instance variable means, sir, I want, observe carefully, the point is, if the value of variable, see here, the value of a in x is different, the value of a in y is different. That means what? This is a separate copy and this is a separate copy. Whenever you are going to create, any object, for that object, what is going to be happen? Instance variable will be created for every object. Observe carefully. For every object, a separate copy of instance variable will be created. Instance variable will be created. That means what here? X is one object and Y is one object. So for X and Y, a separate copy. This is a separate copy for X and this is a separate copy for Y. Okay. Next. So where these are going to be stored? These are going to be stored inside where? Inside an object. Generally, all runtime, sorry, here not here. Where these are going to be stored? Instance variable will be created, right? KIET, see here. Instance variables are going to be created inside a heap memory as a part of object. That means what? Generally, the runtime entities are going to be created inside heap memory. Okay, so that objects are going to be created at what time? Runtime. So the variables are going to be stored inside an object. So finally, I can say what? Variables are going to, instance variables are going to be stored in object. These objects are going to be stored in heap memory. Finally, I can say what? Instance variables are going to be stored inside a heap memory. Okay, this is the point. Next point I want to discuss is, so about this instance variable. So already we have discussed about from where we have to access it. Next, I want to talk about the scope of this one. Sir, what is the scope of this? The scope of instance variable is whenever we are creating an object, automatically instance variables will be created. Whenever we are creating an object, instance variables will be created. Then next term, when those are going to be destroyed, whenever whenever object is deleted, what happens? Instance variables will be deleted. So that means what? The scope of your instance variable is same as the scope of your object. Whenever an object is going to be created, automatically your instance variables will be created. Whenever object is going to be destroyed, automatically instance variable is going to be destroyed. Because what? I can say what? Those are going to be stored in inside an object. So I can clearly say that. Okay. So this is about instance variable. Okay. Right. Now let us go to static variable. And one more important point I have to tell, that is, see here, I have not written any value for this. I have not written any value for that. And 1 minute. So please be in mute. Okay. Okay. So observe carefully here. Whenever we are going to, whenever we are not initializing the instance variable, see here, did I initialize any value to this? No. But if I try to print here, if I try to print the x value, sorry, if I try to print the a value of an object, then what is the value it is going to print? Means whenever you are not going to initialize instance variables, your runtime, that is nothing but Java virtual machine, is going to initialize these instance variables with a default values. Sir, what is meant by default values? Already we have discussed in previous sessions. There is nothing but what? For all integral types, that is nothing but what? Byte, short, int and long, default value is 0. For all floating point types, that is nothing but 0.0, default value is 0.0. For boolean, default value is false. For char data type, it is nothing but null character, which indicates no value. So let us see what happens. Okay. Now see, I am going to execute this one. So I will remove this one. Okay. Right now observe. It will be clear for you. So now I'm going to execute this. You have to get what? Default value. Default value means what here? As it is int type, the default value for all integral types is what? 0. So we have to get answer as what? 0. I think it is clear for you. Okay. Sir, if I take boolean, what happens, sir? I told you already. If I take boolean, default value of boolean is what? False. So I have to get answer as what? False. Let us see that. See now. The answer is what? False. So these are the important points regarding to your instance variable. Every point that is has discussed here. Let us see once again. The variables which are written inside a class directly are called as what? Instance variables. If you want to access instance variable from instance area, we can access directly. To access instance variable from static area, we have to use what? Object reference. So when instance variables are going to be created, so where it is going to created? Inside a heap memory as a part of object. So for every object, this particular instance variable, a copy of instance variable will be created. And finally, what is the scope of your instance variable? So the scope of instance variable is same as object, because whenever an object is going to be created, at that time your instance variable will be created as a part of object. When those are going to be deleted, whenever object is going to be deleted, automatically your instance variables is also going to be deleted. So this is about instance variables. So whatever the point here we have discussed, same type of points will be seen in our static variables also. Everything will be same. Sorry, the content is same, but the place or some other points are going to be added here. Everything will be same. Let us see that. Right. Now I am going to talk about static variables. Okay. Right. First point. So same for every point I will show you the example. So static variable. So first point I want to discuss is there whenever you are going to create instance variable, for every object that instance variable is available. Okay, but here only one copy of static variable will be created. Only one copy of static variable will be created. To whom? For entire class. For entire class. That means what, sir? That means in previous example, what I have shown you, I have created an object X, I have created an object Y. Their instance variable is A. So A equal to 10, a separate copy is created for X, and A equal to 10, a separate copy is created for Y. But now what I am talking about a static variable. If you are going to create any static variable, it will be created, only one copy of the static variable will be created for entire class. What is the meaning of entire class? Means for all the objects of that class, there will be only one copy. So I want to show you the proof for that. Let us see that. So just what I am going to do is I am going to change it as static. Anyway, I am going to take two things. One is static, another one is instance variable to show you the difference. So static int b I am going to take. B value is 20 here for suppose, and a value I am going to take it as 10. Now if I create this one, what happens internally? So see here, I am going to take one more variable. So both are same type of variables. Now if I create these two variables internally, what happens? So see here, same way as we are having instance variable A, for every variable, for every object a separate copy will be created. But this is what? Static. If it is a static, only one copy will be created for all the objects of that class. That means here a separate copy, and the value is what? 20. Now this is available for this object and this is available for this object also. Okay, right. Now I want to show you the proof that as it is created only one copy. So anyway, first I want to print what? I am going to print a value in both, what is that? X and Y. And what I want to print now? The value of what is that? Instance variable, sorry, static variable. Now see, so here first I want to show you what? I want to change the value. First I want to change the value here. X value, A value in X, I am going to change it as 100. Observe now. So now if I print this one, what I am going to get? 100 here. And what I am going to get here? Here I am going to get which value? 10 value, basic value, so initial value. Okay, now see here, I am going to take same thing for, what is that? Same thing for your, right, static variable. So how to access static variable? As it is within the same class and within the static area, I can access directly without having anything. So no problem. Now, here the name of your static variable is what? B. So I can access directly. No need of having, okay, two things. So anyway, if you are going to confuse among these, just first I will tell you x dot b. So later I will tell you why I have written this one. First observe now. So x dot y and x dot b and y dot b. Now observe here. I am going see y is changing the value. So otherwise, X is changing the value of B. So as 200. Now observe carefully. According to X, what is the A value? 100. According to the X, what is the B value? 200. Then according to your uh, X and Y, what is the value of B here? Observe. What is the value of B? According to X and Y, the value is 20 only. But X changes the value of B as what? 200. That means if X is asking B, it has to give 200. If Y is asking B, it has to give 20 generally. If it is a separate copy. But what I told you, both are having the same copy. It is a single copy. So if X is changing this, it will be affected for Y also. Which type of data it is? It is static type. So X is changing B value, which will be affected for Y also. So X is changing Y value here as, sorry, X is changing B value as 200. So if I print X dot B, I am going to get 200. If I print Y dot B also, I am going to get 200. Let us see that. But what about your instance variables? So X has changed its instance variable to 100. Only the copy of instance variable A inside X will be changed, but not the A value that is present in your Y. You can observe the output clear, then you will get a clear idea about that. Right. So see, in first case, in A case, what I got? X is going to change A value as 100, which is not affected to YA value. Okay, so that YA value is always what? 10. Next, coming to this, X has changed the value of B as to 200, but it is affected for what? Y also. So that observe here. So this diagram will give you a clear idea. If you are going to create one more, for example, after this, I am going to create one more object. Okay. I'm going to take that object name as object reference name as what? Z for suppose. If I ask Z also, what it is going to give me? If I ask Z value here, observe Z, the value of A in Z is 10 only, but the value of Z in, sorry, the value of B in Z, sorry, if I am accessing B with the help of Z also, I am going to get what? Similar value, that is 200. So observe now. That means what? Instance variable is for every object a separate instance variable will be there. But what about your static variable for entire class? That is for all the objects. For all the objects, the static variable is common. That there is no concept of separate copy. There is a common copy for all the objects. I should not say it as an object because generally, so we can access, observe carefully, we can access static variable with also this by using object reference, but it is not recommended. Again, I'm repeating the same thing. You can access static variables with the help of object references, but it is not recommended to use. Then what is recommended to use, sir? You can use what? Class name. Whenever you are going to use any static variable or any static member, it is recommended to use class name. For example, you know static method, that is nothing but parseInt. ParseInt is a static method. So to access that or to use that particular method, I have to use what? Class name. Where your parseInt method is present inside a integer class. So how I have to use that? Integer dot parseInt. In the same way, it is recommended for all static members to be accessed only by using class name. Otherwise, sir, my static member is present in the same program, same class. In the same class, sir. See here, test is present here. Inside a test only, static member is there. To access that inside a static area, so I can directly write. There is no problem. If I write B also, I am going to get answer. Observe this one also. Inside the same class, I can access the member directly. There is no problem. So see, directly I got 200 value. Okay. Right. And also if we want to get this one, I can use what? Class name also. Class name also I can use. Sorry, 1 minute. I will save this and I will execute. Right. Sorry, 1 minute. Right. Now observe here, I am going to compile once again and I'm going to execute. So see, same 200 I'm going to get. That means what? We can access static member by using an object reference or a class name, or if the static variable is within the same class, I can access directly. Okay. And also, sir, as this is static area, I am going to access the static variable directly. No, you can access, observe now, you can access static variable directly, observe now, directly from your instance area also. That is, so if I already told you, if I write any member directly inside a class without static keyword, it can be considered as what? It is considered as instance only. So I have created instance method and 1 minute. Okay. I'm going to have what? I'm going to write just a print statement, and directly I can access. There is no problem. Directly I can access what? B. So just I'm going to comment this. Okay. One minute. Right. So now let us execute this, and to print that I have to call that method. So by using X or Y I can call it X dot high. Okay. Now observe. I can access static variable directly inside the instance area also if it is present in the same class. Okay. Now let us check that. See what I got? Only 20 I got. Okay. Right. This is about how to access and where I have to create a instance variable and how many copies are going to be created. Next important point I have to discuss is where it is going to store these static variables and how what can I say, when it is going to be created. Okay, when it is going to be created is first part. I will discuss about when it is going to be created. Previously, I have discussed about instance variables and told you that instance variables will be created as a part of object inside a heap memory. But what? Sorry, the scope is what? When those are going to be created at the time of object creation. What about this? Very important point. So your static variables are going to be created at class loading time. Whenever your class file is going to load, okay, class loading time. And next, when it is going to be destroyed, class unloading at the time of class unloading, sir. What is this class loading and class unloading, sir? So you have to understand clearly that, observe here, in my program, whenever I have written some test here, observe carefully, whenever I require some test, so your JVM has to understand what is meant by this test, so that what it is going to do, it is going to bring that class file, it is going to load that class file. So I'm going to write these steps clearly. So first, clearly I will tell you this one. So if you are going to execute any program, so compilation is what? Java C space test.java, for example. And next, after successful compilation, whenever I am going to execute this, internally what happens, I am going to tell you stepwise. First, whenever I am going to type this one and after pressing the enter, first thing, your JVM is going to start. JVM is going to start. Okay, this is first thing. And JVM is going to create a main thread. JVM is going to create what? A main thread. And what is the task of main thread? To execute a main method. It will execute what? A main method. Okay, sorry, sir. Anyway, okay, sir, main thread is created. What is the task of main thread? To execute a main method. So where that main method is present? Inside a class test. Inside a class test. Already you know that after compilation, for every class inside this program, class files will be created. Observe carefully. Class files will be created. So now what happens? So whenever I'm going to write Java space tester, so automatically I want this class now. I want this class so that your main thread, okay, your main thread task is what? Your main thread task is to execute your main method inside a test class. First, it needs what? Test.class. So that first it will search for that test.class, and if it is available, so I can say what? Search, and if it is available, or we can say it is going to locate, okay? It is going to locate class file. That means what? Locate class file. That means it is checking for the class file and it has seen that class file. Next, what it is going to do? It is going to load that one after locating that particular tester.class by the main thread. It is going to load that file, load that test.class file. In at this time, whenever we are loading this class file, static variables will be created. Static variables will be created. Next one. Okay. Next. So, okay, sir. Now I got the test.class. What your main thread is going to do? It will execute main method. Execute a main method where it is inside a test.class. Anyway, main method is completed now. If main method is completed, 1 minute. Okay. So when main method is going to complete, what happens? Automatically the task of your main thread is going to be completed. So automatically your JVM is going to terminate or kill which thread? Main thread. So main thread is killed. Is there any task for JVM? Finally, JVM is going to shut down. So these are the steps. Sorry, one more thing I have to tell. JVM, shut down the JVM. Before this one, after executing main thread, is there any task with this class file? No. So here important point is, I have missed mainly that unload class file. Unload what? Class file. So whenever we are going to load the class file, static variables are created. Whenever we are going to unload class file, at that time static variables are going to be destroyed. So finally I can say you what? Your static variables will be created when a class file is loaded, and those are going to be removed or destroyed at the time of class unloading. So this is about the scope of your static variables. And next point and final point, sir, where these are going to be stored? Anyway, those are creating at the time of class loading, and those are going to be destroyed at unloading the class file time. Now, where those are going to store, sir? The static variables are going to be stored inside a memory called as method area. What's the name of that memory? Method area. Your static variables will be stored in method area. Okay, right. So where those are going to be declared, sir? If I want to declare a static variable, where those has to be declared? Inside a class. Observe carefully. You can observe this one. I have shown you. Inside a class directly. See here. Inside a class directly, but by using a keyword called as what? Static. By using a keyword called as what? Static. So this is about the concept of static variable. Same concept as we have seen previously. Observe now. Here I have not taken b value, but I have taken 1 minute. I will remove this one also. Right now, see here. I have taken a value, but not b value. Previously, what I told you, if I am not going to initialize the instance variable, then who is going to provide values for that? JVM. In the same way, whenever you are not going to provide the initialization for the static variable also, what happens? Your JVM is going to provide default values. For suppose, first one I have printed what? A value, and second one I have printed what? Test value, sorry, B value. Now tell me what is the A value? That is nothing but instance value, instance variable 10. So that I'm going to get x dot a means I'm going to get as 10. What about B value? I have not initialized any value. If you are not initializing any value for static variable, by default, what happens? JVM is going to initialize those static variable with default values. Let us see that what happens. So let us save this first. Saved. Now observe. So what I got? 10 and 0. Why 0? Because it is initialized with 0 as a default. It is a default value for your int type. Now I'm going to make it as boolean. Already you know that boolean default type is what? False. So you can see what? 10 and false. So this is about the concept of static variables in detail. Okay. Next, coming to local variables and the last type of your variables. Now, sir, what is local variables? It is very easy when compared to those two. A few points will be there for these local variables. In the name, it says what? Local. Local means what? It is going to belong only to a particular area. So, what is meant by area, sir? Previously, what I have discussed, static area, instance area, but here a particular area is nothing but a block of code. Okay, if I am going to declare, if we want to declare, sir, what is the need of? Sir, already we are having static variables and also instance variables, sir. What is the need of these local variables? Observe carefully. Whenever whenever we are traveling to from one city to any other city, there is a no need of mechanic for our car. But unfortunately, if our tire is going to be punctured in between, what we are going to do? Compulsory, there is a need of your mechanic temporarily. That means what? Whenever you are going to perform any task, if there is a need of any temporary requirement or temporary variables, then we have to go for the concept of local variables. What is the concept? Whenever, that means what, sometimes for our task, if there is a need of any temporary requirement, then we can declare our variables inside that particular method or a block or a constructor. Such type of variables are called as what? Local variables. Anyway, these local variables is also called as so temporary. These are called as what? Temporary variables, or these are going to be called as local variables are going to be stored inside a stack. So I am telling directly here, your local variables are going to be stored inside a stack. So those are called as what? Stack variables. And as these are going to create automatically when a block is going to be created, sorry, when a block is going to start the execution, we can say that automatic variables automatic variables, whenever your block is completed, automatically these variables are going to be destroyed. So these are called as what? One is local variables is also called as temporary variables or stack variables or automatic variables. Okay, right. So you know that where those are going to be stored inside a stack. So main only these points are important. Again, one or two more important points will be there for this. So observe carefully here. Local variable will be, already I told you, local variable will be created as a part of what? Sorry, whenever a block is going to start its execution. Clearly, I will show you an example now. Please observe carefully. So it will be clear for you now. So see now, just I don't want to talk about this. Just I'm removing this. Just I want to talk about a block or any method or anything. So anyway, see now. So here this is a method. This is a method which indicates this is the starting of a method and this is ending of a method. If I am going to declare any variable inside this method, it can be called as what? A local variable. So here I have declared this a and I'm going to take the value of a as 0. That means what? This is a local variable for our main. So it can be accessed only within this main. It cannot be accessed outside of the main. First point is completed. Next one, I am going to take one more block. Listen carefully, one more block. And here I'm going to take what? I'm going to take one more variable. Int, for example, I will take int b equal to 0 and for example b less than 5 and I am going to do what? B plus plus and listen carefully now. This is important point. Now here for this for loop also I have declared this b inside a for loop. That means what? This b can be accessed only within this for loop, not outside of the for loop. If I write b here, already I have written a here. From where to where a is going can be accessed entire this a is declared inside a main block or main method. So it can be accessed from this bracket to this flower bracket to this flower bracket. The scope of your local variable is within the same block. Once if you are entering into that particular method or a block, a local variable is going to be created. Whenever you are going to get out of that block, a local variable is going to be removed. Now, again I'm repeating, this a can be accessed in entire void main and this b can be accessed only within the for loop. So now I am going to show you, I am trying to access and I'm going to perform some operations like a equal to, I'm going to write a plus b for example. Some operations I'm going to perform and after completing the operations, I want to see what will be the output of your 1 minute. Okay. What will be the output of A and B? So now see here, just I'm going to write A and I'm giving some space and I'm going to print B here. So according to you, you may observe that there is no problem in the program. So A is here and B is here. B value is here. So just, okay, anyway, here, okay, anyway. So now what I'm going to do, just I will print this. You may think that, sir, after operation, A value is going to be changed. After this after all the iterations, B value be incremented to 5 and B value has to be printed as 5. But you are going to get an error. Observe now. So see, 1 minute. So previous program is going to generate it here. I'm going to save this. Sorry. So as these two are also, now observe. I'm going to save this. We are going to get an error. See, observe carefully. Cannot find symbol B. What it is telling, sir? Already we have declared B. But why it is telling we are unable to see B? Because where you have declared B, already told you. I have declared B inside a for loop. So it can be accessed from here to here. That's it. I am trying to access the B value outside of this block. So what happens? Automatically you are going to get what? Error. So because it is declared outside of the block. Okay, sir? Okay, sir. Now, sir, block means what? Is it a for loop? Is it a if? Or what a block means? Block may be anything which is started with flower bracket and closed with flower bracket. So this type of things you have seen in for loop, if, while, do while, try block, catch block, finally block, constructor, static block, instance block, all these are considered as a block of code. Okay. If you declare anything inside a block, compulsory it has to be accessed only within that block. Okay. Now see here, I will take a small example here. I am telling what here I have taken. Okay. Just I will declare one more variable here. Int x equal to 20. Okay. Right. Now tell me this x and b are only available for what? Within the for loop. Here one more important point I want to tell you. Just I will remove this from here. Okay, just I will write it here. Okay, right. Anyway, within the for loop, I can access x, access b, and access a. Just I want to show you what will be the value of x. And that means what? I am showing you scope and lifetime. Okay, already I have discussed about scope. Now I am discussing about lifetime. What is the lifetime of this particular b? Until the completion of this for loop, this b is available, or this I am talking about x for example. Until the completion of your for loop, this x is available. After completion, what happens? It is going to be destroyed. If we come out of the for loop, x is going to be destroyed. Okay. Next, observe carefully. Let us take a small operation on this. X equal to x plus 1 or x plus plus anything. So now tell me first time b equal to 0, and here I am coming to x equal to 20 and x equal to x plus 1. That means what? X value becomes 21. If I print x, 21 is going to be generated. Next I am going here and again I am performing what? X plus 1. The answer is 22. Next 23, 24, 25. For example, you may think in that way, but what is going to be happened here? Now observe. First time when I'm coming, when I'm initializing b, the value is what? 0. It is going to check the condition. B less than b. Yes, condition is satisfied. Now I am entering into for loop. Whenever you are entering into for loop, here this local variable is created. And the value of that local variable is what? 20. And I am performing some operation on that variable, that is nothing but x plus 1. Now what happens? X plus 1 means what? 20 becomes 21 and stored in the same variable x. Now x value is what? 21. I have printed it here. The value x is printed. Now what I am doing? I am coming out of the for loop and again I am going to perform b plus plus and I am checking the condition. So b plus plus means 1, 1 less than 5, condition satisfied. Again I am entering into for loop. Once you have left, this variable is destroyed. In first loop, it is whenever we are coming out, this variable is destroyed. Second time I am coming in, again a new variable is created here. Again x is created, 20 is inserted. And again what happens? The 20 value is going to be added with 1 and x value is what? 21. If I print x, I am going to get answer as what? 21. Let us check. See now, how many 21s are there? It is not 21, 22, 23, 24, 25. It is all are 21s. So by this example, I think you got the scope, lifetime of your variable. Okay, the same concept will be applicable for all the, it may be a try block, catch block or anything. Okay, right. One more point, important point I have to discuss, sir. I have not given any value, sir. I have not given any value for this A. Previously, what I told you, if you are not going to initialize, okay, if you are not going to initialize this instance variable and static variable also, your JVM is going to give you the default values. But here in this case, so these two are commented, these two will not be considered by our compiler. A means only this A. So now observe. Now what happens? I have not given any value for A and I am trying to access it. Okay, then what happens? Observe now. Sorry. I have not compiled. Right, now compilation is going to be done. Clearly observe here what happens. Clearly your compiler is saying that variable A might not have been initialized without going to, very important point, without initializing any local variable. It should not be used. Again repeating, without initializing local variable, we should not access it. Okay, for example, I have not initialized and I am not accessing that. There will be no error. Okay, once again, I will print some hi message. Am I accessing here A here? I am not accessing. Then there will be no problem. Observe now. See, I am going to get answer as what? Hi. There is no problem. Meaning is, if you are going to create any local variable and without initializing that, if you are trying to access, we are going to get an error. But whenever you are going to declare any local variable and it is not initialized, and also if you are not using it, there will be no problem. This is that second example. Okay, this is about the concept of local variables, and some few suggestions I will give you that please don't please don't initialize the values of your local variables inside the for loops. For example, I want to write 20 greater than 10 and I want to initialize whenever 20 is greater otherwise I don't want to make you confused. I'm going to write take some values b equal to 20 and c equal to 30 for suppose, and here I'm going to write some condition. Okay, Right. 1 minute. Okay. So here what I am going to do, I am going to take B value. Observe. B is 20 and C is 30. I'm going to take 30 and I'm going to write less than. Now see, just whenever it is going to be happened, as you know that if there is single line for if, no need of writing flower brackets. I'm going to initialize A value as 40 and I want to print A now. Observe carefully. Now what happens? My program, I have a local variable called as A, B, C. As B and C are initialized, I am not going to talk about those two. I want to talk only about A. Okay, so A is not initialized here, but before using that A, before accessing that A, I have initialized that A to 40. Okay, there is no problem. So observe this program now. What I am going to get? I am going to get answer. Oh, sorry. A is not initialized. So 1 minute, 1 minute. Let us see that why it is going to be 1 minute. Because what happens here? See, is it compulsory that I will enter into this if block? It is not compulsory. I may not tell. If the condition is going to be failed, what happens? You may not enter into the if block. So that it is never recommended to do what? It is never recommended to perform initialization for your local variables inside logical blocks because there is no guarantee of executing that block. There is no guarantee, but as this is, it is possible in this case, the compiler has given a restriction that you may tell the condition is true, but if the condition is false, what happens? It will not be initialized. So that it is never recommended to perform initialization of a local variables inside where logical blocks like this if, else, and so on. And finally, I want to tell you that it is highly recommended. It is highly recommended to initialize the values of local variables. Sir, now I don't want to initialize this, sir. Later I will initialize. Please don't do that. At least you initialize that value with 0. Later, if you want to change it, you can change it. There is no problem. Okay. These are my recommendations according for your local variables. And final point, if you want to write any modifier, that means what? Final, static, public, next one is private, protected, and so on. If you want to write any keyword before this particular local variable, we can write only one keyword, that is nothing but what? A final. Except this final, if you write any other thing, we are going to get an error. Let us see. I will take what? First, I will take public. You may think that it is correct because there is no problem. If you know the rule, then only you can understand why you are going to get an error here. So according to this, what happens? As I know, there has to be what? Error. So let us see what type of error it is going to give. See, observe here. Illegal start of expression. The local variables should not have a keyword or a modifier called as public. If you take private, protected, for example, I will take static. For suppose, I will take static. Okay, now observe. Same case, illegal start of expression, which is going to show you static. It is going to show you the cursor towards the static. Then what I can write, sir? Only final. Only final. Now observe, there will be no problem. See, I'm going to get, sorry, I have compiled and it is successful and I'm going to output as 0 and high because I have initialized this A with 0. That's it. So this is about the concept of what? Variables. Okay. So I have discussed in detail about these variables. Okay. Now, please wait a minute. Okay. So, and one more point, already I told you that there is nothing but what? It may be a local variable or it may be static variable or it may be, once again I'll show you here please. Okay. Now see, I'm going to draw a small diagram for you. I told you what? We are having two types of variables. One is primitive variables and other one is what? Reference variables. But till now, what I have discussed only about primitive variables. I have not discussed about reference variables. And I told you what? There are three types of variables are there. There is nothing but what? Instance, static, and local. So now observe here, your primitive, your variable can be primitive instance, or primitive static, static primitive, or local primitive. And your reference variable can also be instance, your reference variable can also be static, your reference variable can also be local. Okay, so what is reference variables are? If you are going to write any class name or any interface name or any array or any other enumeration, if I write anything beside that, then this variable is called as what? Reference variables. And whatever the rules till now I have discussed, that is applicable both for primitive and reference. Listen this point, it is very important. Whatever the points till now I have discussed, those are applicable for what? Everything. Those are applicable for reference variables and also primitive variables. But just I have taken what? An example of primitive variables only. Anyway, just by having a small example, you will get a clarity about that. See, I'm going to take class test here, for example, and inside this I will take some variables. So that is nothing but int a equal to 10, and next static some int b equal to 20, and next I'm going to create an array here, int c equal to new int of 5, for example. So next I'm going to take public static void main. Okay, I'm not going to write entire thing. String args. Okay, right now observe here. Here inside this I'm going to take one more variable. So now I want to make the things clear with this example. Now see here, as we are writing directly inside a class, this can be considered as what? Instance variable. And this variable is created with the help of what? Primitive data type. So I can call this one as what? I can call this one as what? Instance primitive. Instance primitive or primitive instance. Next, coming to this, I have created directly inside a class, but I am going to use a keyword called as what? Static. So it is, by seeing this, you can understand it's a static variable, and it is what? Int type. So it is what? Primitive type. So this is nothing but what? Static primitive. But coming to this one, C is what? Array. Every array in Java is a object. So this is nothing but a reference. Reference. This is what? C is a reference. Where it is created? It is created inside a class directly. So C can be what? Instance reference. What is that? Instance reference. And coming to this, as this is declared inside a void main method, so I can consider it as a what? First thing, as it is a local, I'm going to treat it as a local. And next to what? This is a class. It is not a primitive data type. It is a class. So this will be considered as what? Reference. So this is nothing but what? Local reference. The rules of instance, static, and local are same for primitive variables and also for reference variables. Okay. So this is about the concept of variables in our Java. Next, let us see the concept of arrays. Okay. Right. 1 minute. Right. Let us start the concept of arrays, which are very important because till now we have taken what? We have discussed about the concept of only the variables where it can store single data. Now, I want to take group of data, sir. I want to take group of data. Is variable is sufficient? No. Every variable can store what? Only single value, as we have discussed till now. But now I want to discuss about uh, an array where it can store group of values. And so as you know that Array already we have seen in our previous languages also. So what is the main concept of array means? It can store group of values, sorry, group of similar or homogeneous values, homogeneous types, homogeneous types or values. Okay, next one. So first point is this, and here if you are going to create any array, size is fixed. I cannot change the size. And here group of homogeneous elements we can have, and also size is what? Fixed. And main point to be understood is, sir, what is the need of coming to this array? So let us take, sir, I want to take 5 integers. I will take a comma b comma c comma d comma e. So there is no problem if you take these 5 variables instead of taking a array with size 5. But if I want to take 100 integer values or int values, can you remember the names of all these 100 variables? It is not possible. So that I am going for the concept of what? For example, I am going for the concept of arrays. Okay. So main point, an array is nothing but what? It is an indexed collection. I am telling you the technical definition. An array is an indexed collection of fixed, already I told you, size is what? Fixed number of homogeneous element or similar data elements. Okay, this is the definition of an array. Once again, I'm repeating. An array is an indexed collection of fixed number of similar values or similar elements or homogeneous elements. So, sir, what is the main advantage of this, sir? So see here, for example, A value is 10. I am taking here A value is 10, B value is 20, C value is 30, for example, for suppose, and these are all are int type. Okay. Now tell me, if I want to print 10, if I want to print 10, what I have to do? I have to print A. Just I will print A. If I want to print 20, I have to write what? B. If I want print 30, what I have to write? C. That means what? Here A is used how many times? One time. B is used how many times? One time. C is used how many times? One time. That now come to other example where I am going to store the data in array. So 10, 20, 30 I am going to store, and I am going to name the array as A here. If I want to print the 10 here, what is the name I have to use? A of 0. Next, if I want to print 20, A of 1. If I want to print 30, A of 2. That means what? How many times I have used this A? 3 times. That means what? I am effectively using the name of an array here, but I am not using effectively these variables. Okay. So finally, I want to tell you that the main advantage of these arrays are we can represent multiple values by using the same name. So that what happens? Readability is going to be increased or improved. Readability is going to be improved. Means what, sir? Generally, if I am using otherwise, I will take a small example. You are going to buy a cricket bat. For example, cricket bat you bought, and your father, after asking several times, your father bought you this cricket bat. After buying, you have asked nearly 20 days, sir, daddy, please bring a cricket bat. And before, from 20 days, you are asking. Your daddy bought that bat after 20 days. And what you are doing with that bat? Just you are going to keep that bat in a storeroom, and you are not going to play with that. What your father is going to tell? You have asked me nearly 20 days or 20 times, so that I have bought you that bat. And what you are doing with that? You are wasting that money. You are not using that effectively. In the same way, we have created a variable, and we are not using this effectively, because see, one time, but see, I have created an array and I am using effectively, because for every value I am going to use what? Array name only. This is nothing but readability of a code or readability of this particular array. Here, readability is going to be improved. How many times I have read A? A of 0 first time, A of 1 second time, A of 2 third time. So here, by using the concept of array, main advantages are what? We are having a single name to access all the elements, and by having a single name, readability is going to be readability of a code is going to be improved. Now, sir, what are the disadvantages, sir? Mainly three disadvantages are there. Mainly, first one is First one is, if we are going to take an array, this type of array, int a equal to, in this way we have to create an array in Java, 5 for example, in this way. Now, what I can store here, I can store only int type and other types which can be promoted to int. Later, I will previously I have shown you that diagram also in previous sessions. Byte, short, next one is what? Int, long, next one is float, and finally double. Okay, and char also can be promoted to int. That means what? If I created int array, all these types can be stored in that particular array. If I am going to create long value, all these types can be promoted to long. There is no problem. If I am creating float array or float variable, all these types can be promoted to float. Okay. Previously I have discussed about this. Now what happens? I am talking about int array. So anyway, these types can be stored. There is no problem. Okay, I'm storing 10, which is valid. But if I'm going to write a of 1 as 10.5, which is by default double type, it is not valid. That means what? It can store only homogeneous. It cannot store heterogeneous. Only homogeneous types. Okay, first point is completed. Next one, second one. Sir, here I have created an array, sir. What is the size of an array? 5. Once if you are going to create an array in Java, the size of your array cannot be increased. There is nothing but what? Size cannot be changed. Cannot be changed. That is nothing but changed means what? Size cannot be increased, or cannot be changed. That is nothing but increased or decreased. So that 5 cannot be changed as 4 or 3, or it cannot be changed as 6 or 7. It has to be only 5. And finally, very important point to be discussed here. I have taken one array, and here I have some elements 10, 20, 30, 40, and 50. Now, I want to perform addition operation on this all elements of an array. That means what? I want to sum all these elements of an array. Generally, what I have to do, I have to take a for loop, int I equal to 0. What I have to do, I less than length. How to find a length? I am going to have a length variable, a dot length, I plus plus I am going to take. And next, what I have to do here, sum equal to sum plus a of I. This logic has to be written by me externally. What is the reason? For everything, if I want to find the maximum element of this array, I have to perform some operation here. If I want to find the minimum element, I have to write some logic. If I want to find average of the numbers, I have to write some logic. So this is unnecessary. That means what? If it is having some data structure internally, for suppose I am having a stack. Whenever I told you a stack, in your mind you will get 3 methods. One is what? Push. Another one is what? Pop. And last one is what? Peek. But whenever I am talking about an array, in your mind, are you getting any method names in your mind? No, because your arrays are not having any data structure, any inbuilt data structure. So that what happens? Inbuilt data structure. So that it is not having any methods by default. Okay. So for everything, for every operation, I have to write the logic. So these are the 3 disadvantages of the array. Anyway, to overcome these, I am going for the concept of what? Collections. There is no problem about that. Okay. Right. This is before going to see anything, we have to see some of the advantages and disadvantages. We have seen that. Now, how to create an array? How to create an array? How to declare an array? How to create an array? And how to initialize the array? Just I am going to tell you clearly. First one, declaration. First one is what? Declaration. That is nothing but array declaration. So we are having, first I will talk about single dimensional. Later I will talk about 2 and 3 dimensional. Single dimensional. Okay, let us talk it. As you know, and a general way of declaring this single dimension array is, I am going to write a type, and I am going to write a name, and I am going to write the square bracket open and close. Generally, we are going to follow this one only. But how many possibilities are there, sir? There are three possibilities are there. For single dimensional, I can declare in this way, there is no problem. And also I can declare in this way. It is these three are possible for declaring a single dimensional. You may know only one, but these three are possible. Now, this is about single dimensional declaration. So, before going to two dimensional, you have to understand one thing, where these square brackets are going to be given after the name of an array, after the type, and before the name of a array. Remember these three places. Now I am going to take two-dimensional array. Two-dimensional array. So now see here, already I told you three places I can place those square brackets. There is nothing but uh, dim dimensions here. Okay, now see. Now, first one, as you know, I will write this one after the array name. First type of declaration is completed. Next one is what? After the data type. Second one is completed. Third one is what? Before the name. This one is also completed. So now remaining some other possibilities are also there for this two-dimensional array. What are those possibilities? Those are, you have to see only these three locations. After the name of an array, after the data type, and before the name of a array. Now observe carefully. Int, I will write one bracket after this and one bracket before this. It is valid. Next, I want to write one bracket here and one bracket after the name. It is also valid. Next, I want to write one bracket before the name and one bracket after the name. It is also valid. So all these ways are valid declarations for two-dimensional array. Coming to last one, 3D, three-dimensional. Now tell me how many ways, as you know that. First one, int a, I am going to take after the name of an array, and next int after the data type I am going to take, and next one, int before the name of an array I am going to take. So these three are, as you know that, these three are general things. Now observe. I have to divide all the brackets into three places. First, I will take one here, two after the name of this. Next, I will take one here and before the name. Okay. Next, I will take one here and one bracket before the A and after the A. So next possibility. Just I will take here two brackets here and after the name one. And I will take two brackets here and before the name. Okay. Now see here how many possibilities? 1, 2, 3, 4, 5, 6, 7, 8. Let us check for any other possibilities are there. Yes. Some more few possibilities are there. There is nothing but here. Okay. Anyway, just I will take here. Here I can take 2 and after the A I can take 1. Next I will take, so observe one more possibility maybe there here. Here I will take 1 and after this I will take 2. So all these are different possibilities for declaring the three-dimensional array. Okay, just remember the places after the name, before the name, sorry, after the name, after the data type, and before the name of an array. Now the point is here, sir, you have written these many types of declarations. Which one is recommended to use? Observe here. First, let us talk about single dimensional. So this one is recommended. You may tell first one is recommended, sir, because generally we will use first type. But as we are using it, it is not recommended. Reason. So now see, recommended type is this one. Sir, why it is recommended, sir? Observe carefully. Here, what you are observing, I am without seeing this, what I can understand? Type and dimension. So by seeing this, what can I understand? This is int type and it is one dimensional. So which is separated by the name. So there is no problem. Otherwise, for example, A comma B comma C. Now what happens? Clearly we are going to separate the type and dimension and the names. So this one is recommended, and in this case this one is recommended, and in this case this one is recommended. So these are in these ways we can declare our array. You can use any one of the declaration form. Okay. So it is not compulsory to have only any one type here. Okay. Next, one more last rule for this declaration, that is, sir, you told three places. That is nothing but what, after the name, before the name, and after the data type. But there is one important rule is there. If you want to mention a size, sorry, a dimension in front of the name, it is applicable only for first array name. Here, how many array names are there? One, two. So the rule is what? If you want to write a dimension in front of the array name, it is possible only for the first array name. From second array name onwards, it is not possible. That is, for example, here A I am taking, for this one I am taking, and for second one also I am trying to take. Here I am going to get an error. Reason, if you want to take this one, it has to be taken only before the first array name. It is not possible. Sir, is it possible for third one? No. So the rule of having the dimension in front of the array name is only applicable for first array name only. From second name onwards, you should not take the dimension in front of the name. Sir, then if I want to take that, what I have to do, sir? You can take it, but don't take before it. You can take after that. There is no problem. So this is about the concept of what? Array declaration. So in next session, we will see the concept of array creation, and also next one is array initialization also. Any doubts? If you are having any doubts, you can send through the chat box. Okay. As you are not having any doubts, okay, thank you. Okay, thank you. Right. Okay, Ma, I'm going to end the session. Thank you.
Thank you.
You can leave.